Hello and welcome to another math tutorial. This week we're going to try something a little bit different. As you can see, I decided to go old school for a bit and do things on paper. Because my writing probably looks better on paper, so that's what we're doing. And we're using an ink pen. Yeah, very fancy. So we're gonna go ahead and look at our question. And this is, as always, a circle problem. So let's go ahead and do it. The question asks, find the equation of a line that passes through the center of the circle. X squared plus y squared minus 14x plus 10y plus 73 equals 0. And is parallel to the line 3x plus minus 4y equals 7. Well, there are a couple of things you want to highlight here. So the first thing, obviously, I want to highlight the word center here. And we also want to highlight parallel. Well, circle, the center of a circle is pretty generic, right? You have your circle, right? Yeah, this is graph paper, so which is really nice. And there's our center. And then we denote it by O right over there. And parallel in mathematics has a very specific meaning. You have your two lines, right? And then when we say two things are parallel, we mean that their slopes are equal, so their rate of change is equal. So you have m1 here, and then m denotes slope, and if they're parallel, that's the case. m1 is equal to m2. And that is all the properties we have so far. Now, so how would we determine what the center of the circle is? Well, first thing, we don't want to be dealing with this nasty form of this equation of a circle. So, and therefore we need to manipulate it. So we want to get into this form, some form of, so this, we wanted to get into the form of x minus alpha squared plus y minus beta squared is equal to r squared. What's that mean? Well, and then where so that right there is the form we need. And what we're going to do is try to use what we have here and develop another form of the equation of a circle and turn it to this form. So how do we do that? Well, let's see, right? So let's just go ahead and write that equation down again. And before we manipulate this, right, we're gonna do a quick recap. So we're gonna use our pencil of how to factor and complete the square for a regular trinomial. So what you have, so normally, right? So we're gonna consider we have something along the lines of x plus a squared. Okay, we're gonna consider this equation right here, and we're gonna just gonna expand it. So we want to have x plus a times x, and you know from middle school, right? You learned FOIL. You have, and so you have first, outer, you have first, outer, inner, last, right? So if we do that, that's going to be x squared, right? X times x plus x times a plus x times a, right? Plus a squared. And what's that going to give us? X squared plus 2ax. Okay, pretty basic stuff, right? Except we want to highlight something here, right? So pay attention. So what we've really done here, right, is essentially, so if we look at these two terms, and you notice the coefficients of x, and so you have this coefficient and that, and you'll notice the coefficient of x is actually double. And similarly, if you had something like if you had something like maybe x plus a over 2 perhaps, and you would know that would be just a, and then that's your coefficient of x, and plus a over 2 squared. And in fact, this is the form we need to be able to convert from this to this. So you want to try to get into some form of this so that we can complete this square and get it to this form. So we're gonna look back at our equation, and so the first thing we want to do is we want to group the x's together. So this is going to be what? X squared minus 14x, right? And plus y squared plus 10y. And the 73 is just a constant for now, so let's just group them. Now, here comes the punchline. So we're gonna highlight this. So we're gonna look back at our equation here. Okay. And you'll see that's negative 14 right here is our a right here. So to be able to complete the square, we want to find a of 2 and then squared. So what we need to do oh, and also we also have our 10x right here. And to get the third term here, and then this is, so in this case a equals 10. To get the third term, to get our trinomial, we must add half of it, half of 10. So what we really want to do is we have x squared minus 14x, and we're gonna add to it negative 14 over 2. And we're gonna square it. And same thing for here, same thing for y. We have plus, all right, plus 10 over 2, right? We see where the a is coming from, and obviously this is, you gotta add 73. Oh yeah, we ran out of space. That is equal to 0. So yeah, that is the main step here. And now you'll notice we've essentially added 2 extra terms, right? So to be able to retain what we have from the start, and we gotta subtract. So essentially what we've done, we have x squared plus 14x. Oh wait, no, this is minus. Plus that's negative 7 squared, which is 49, plus y squared plus 10y plus 10 over 2, that's 5 squared, which is 25. And after that, we must subtract our 49 and to subtract our 25 to counteract what we've just done, which is also, this is still equal to 0. So now we can see, right? This is exactly the form we want it to be in, right? Because then we can complete the square, right? We can use our this relation right over here, and all this will turn into what? Well, it's going to be x plus our a value, our a over 2 value, right? These are the same. This is exactly what this is exactly what we're looking for. So that's that's our a over 2 value, which is negative 7, and we want to square it, right? Square it, and plus same thing, y plus a over 2, which is 5 squared. And now we can just go ahead and simplify this, right? So this would be what? Well, let's find out. Negative 49 minus negative 1. And just to see that is kind of there. And of course, that's still equal to 0. So now we essentially just converted it, right? And now the last step is to just, well, we want the equation to be in this form right here. So therefore, so this is the same as x minus 7 squared plus y plus 5 squared is equal to 1. And therefore, there we have our equation of the circle.